Can you all hear me? Everyone, can you hear me? So sorry, there was a sudden internet problem and it got completely disconnected. Let's continue. Let's continue. Okay, so I was actually writing this one, right? Okay. So I was saying that we charge this. Uh, so so we are charging this 10 volt 2 ohm we are using this 10 volt 2 ohm battery to charge uh, let's say a 5 volt and 1 ohm battery, right? Let's say we have this sort of situation. All right, so what we are given is that we are using, suppose, a 10 volt 2 ohm battery to charge a 5 volt 1 ohm battery, right? So what this means is, of course, if you look at how the batteries are connected, right? I'll just erase these rectangles for a while. If you'll have a look at how the batteries are connected or cells are connected, you'll realize that if you talk about the battery 1, it will try to make current flow. Battery 1 will try to make current flow in a anti-clockwise manner in this circuit. Is that okay? So battery 1 will try to make current flow in anti-clockwise manner, right? Okay, but if you would look at the battery 2, if you would look at the battery 2, right? This battery 2, this battery 2 will, this one, right, will try to make current flow in opposite manner, right, in the clockwise manner, right? That's what the battery 2 will try to do. So actually these batteries are opposing each other, right? And in such, this is exactly a situation where the battery may get charged, right? Only in such situations the battery can get charged. So what will happen is battery 1 is used to charge battery 2. Okay, so in this situation, if we want to find out how much is the current flowing, if we want to find out how much is the current flowing and what is the terminal voltage, right, then for battery 1, I repeat, for battery 1 we will have to use V1 equal to epsilon 1 minus IR1. I hope that is clear, because this battery 2 is getting this battery 1 is getting discharged, right? On the other hand, for battery 1 for battery 2, excuse me, for battery 2, for this one which is getting charged, you would have to write terminal voltage V2 equal to epsilon 2 plus IR2. Okay, I hope that makes it very clear, right? Okay, so in such cases, if you would find out the current, right? If you would find out the current, in the current, for finding the current, the procedure would be as follows. Do you realize that 10 volt EMF of epsilon 1 or first battery is actually opposing the 5 volt EMF of the second battery, correct? So the net EMF is only equal to 5 volt. Clear? I hope that makes sense. Yes or no, everyone? because these two oppose each other. Have a look. So the net EMF is only 5. Is that clear? Why is it 5? Obviously we are doing 10 minus 5 because these two are opposing each other. Remember these batteries are in series. Do you see that? Do you see that these batteries are in series? Right? I'm trying to build an intuitive idea of how things work here. I don't think most of you have understood, right? Very few of you said yes. So I believe most of you have not understood that. What, Avinash? What? Yes, you have not understood? Okay. Is everyone there? Okay. All right. I'll just repeat it very quickly. What I'm saying is that this situation is like 10 volt battery or 10 volt EMF in this manner, right? But this 5 volt is trying to make current flow in opposite manner. So that is like this. I hope that makes sense, right? So this 10 and 5 are opposing each other. So the net or the total should only be 10 volt minus 5 volt EMF, that is 5 volt. Clear? So the net EMF should be 5 volt. That's what I'm saying, right? Okay. So, and if you will then have a look at, if you'll then have a look at what's the total resistance in the whole circuit, then the total resistance is 3 ohm, right? Then the total resistance of course is 3 ohm. Why 3 ohm? I hope everyone understands why it's 3 ohm, because there is 2 ohm here and then there is 1 ohm here, and all that is in series. Yes. Avinash, you don't say amp. Amp is wrong word. Okay. Unit is ampere. So just write capital A. Writing AMPS is wrong. Do not use everything that you learn off the internet. All right. Because internet doesn't have to follow all the rules of science. Correct. So yeah. Now, so total current or the net current in the whole circuit is only going to be 5 by 3 ampere. Clear? I hope that makes sense to all of you, right? The net EMF is 5 volt and the total resistance is 3 ohm, for example, right? So it's going to be 5 by 3 ampere. Now, so once you do that, you can easily find out the terminal voltage, right? Once you do that, you can easily find out the terminal voltage. All right. So for battery 1, it's going to be very simple. I'll just do it very quickly. Okay, I will not wait for you. You can start doing it along with me. Okay, so that's the terminal voltage for the first battery, right? Okay, you can clearly see it's about 6.67 volt, right? It's 6.67 volt. Now it's of course less than EMF, right? Its EMF was 10 volt, but its terminal voltage is less. That is because it is discharged. That is because we are using energy from this battery, and this battery will drive the current, right? I hope all of you get that. This battery is what is responsible for this direction of current. Okay, that's why it is getting discharged, and that's why the EMF is less, because if you use this relation with a minus sign, of course it should be less. Now V2. For V2, the the potential difference, sorry, for the second battery, the EMF is 5 volt. All right, epsilon 2 is 5 plus. Now what's the current? Again same current, 5 by 3, because there is no split or there is no branching anywhere in this whole circuit, right? Okay, into R2 is 1. So this is going to be once again 20 by 3 volt, and this is not a surprise. Okay, this is not a surprise, because here there is nothing else in this whole circuit. If you look at these 2 points, suppose let's call them A and B, and you call this C and D, right? Okay, so what we are having is potential difference or voltage between A and B should be same as voltage between C and D, because there's nothing else, right? And that's why we are getting both these answers same. But you can clearly see that this terminal voltage is bigger than EMF. All right, this terminal voltage is bigger than the EMF. The reason is that this battery is getting charged, right? Okay, so that's not a surprise actually, right? This is 6.67 again, which is bigger than 5. That's because this second battery is getting charged, right? એટલે આવું થાય છે, નહીતર આવું ન થાય. Okay, in any situation, right? So I hope you have realized that this is how we typically do it, right? We can find the current first, and then we can find out the terminal voltages. બહુ અઘરું કઈ છે નહીં ખરેખર, આ તો પહેલી વખત છે, right? So now we are actually going to solve this exercise question 11. Okay, let's solve exercise question 11. All right, I believe that is related to this concept. Okay, okay, all right. Here's the question. So first thing first, draw the circuit, everybody. Come on, draw the circuit on your own. See if you can get it right without my help. I'll give you 1 minute to draw the circuit. Okay, after that I will draw it. Okay, looks like you're done, everybody, is it? Okay, so here is my diagram. Clear? Does it match with what you have done? Does it match? Or is there anything that you'd like to ask? Very good. Well done, people. હા, તમે એમ ન કહેતા સર અમે તો અહીંયા એક જ કર્યું છે, એવું બધું ન જોવાનું હોય, એ ચાલે. ધેટ્સ નોટ અ કન્સર્ન, રાઈટ? Okay. So the question is, what is the purpose of having, no, sorry, I first I have to read this. What is the terminal voltage of the battery during charging? So we have to find what's the terminal voltage of this one. Okay, we have to find what's the terminal voltage of this one. All right, so just like I gave you an example earlier, we are going to follow a similar procedure, right? So first step is to find current. Okay, so you could write net EMF in the circuit. Okay, what's the net EMF in the circuit? Come on everyone, tell me what's the net EMF in the circuit. Hurry up, come on. અમુક લોકોની બેટરી ડિસ્ચાર્જ થઈ ગઈ લાગે, જવા માંડ્યા. They don't want to learn charging. Very good, very good. I've got all correct answers so far. Well done people. No Swarali. No Deval, no way. No Darshi, come on. Net EMF, net means total EMF. કરંટ ક્યાં પૂછ્યો મેઘા? કરંટ નથી પૂછ્યો. Everyone, the net EMF in the circuit is 120 minus 8. I hope that is absolutely clear, right? I hope that is absolutely clear. Net EMF, total EMF in the circuit is 120 minus 8. Right? આ તો બધા રેઝિસ્ટર્સ છે. આ રેઝિસ્ટન્સ છે ને, ઈ નો ગણાય ને, that is resistance. It is not EMF. Right? Again, why are we subtracting? Reason I've told you that this 120 volt battery will try to make current flow like this, but this 8 volt battery will try to make current flow like this, opposite. Okay, so that's why the net EMF is only 112 volt. Okay, so I hope that's clear. How do we know that we have to find terminal voltage of 8 volt battery? Himani, that is written in the question. Battery kone kidhu છે? જો read the question carefully. Storage battery of 8 volt, બરાબર? અને બીજાને તો એ લોકો supply કહે છે. I hope you see the name, right? This other one, they are calling it a supply, right? I hope you understood that. If both would have been called battery, then it would be confusing, right? Okay, but generally questions will be clear, right? So that you will not have any kind of confusion, right? Okay, so this is 112 volt. Now current in circuit, I is equal to, how much is net EMF? 112, right? There's no doubt about that. અરે યાર લોકો જવા માંડે છે. Come on, you don't even want to solve a question? I'm amazed. તો હવે મારે પછી એવી રીતે સમજાવવું પડશે કે જેટલા રહ્યા છે એમને સમજાય, વાંધો નહીં, થોડાક જતા રહેતો એમે જવાના જ છે. 5 વાગે જાય એને બદલે 4:30 મોકલી દેશું આપણે, એવું જ ભણાવવું છે. So this is 7 amps, all right? Then alpha it will be 0. Okay. we have a new student in our class. My nephew also wants to learn some physics. So, so current in the circuit is 7 ampere. Now terminal voltage. Sorry for the interruption. So terminal voltage of this battery V equal to epsilon plus IR, right? Let's put all values and we'll get answer. So what is epsilon? 8 plus I. What is I? Current is 7 into internal resistance is 0.5. Okay, right? So this is going to be 8 plus 3.5, so that is 11.5 volt. Clear? Okay. Avinash, it has some other purpose. Okay, so that's it, right? I hope this is clear. Please don't use the wrong formula. Don't use this, because this formula is used when this battery is discharging, right? Okay, here, yes, Avinash, that is right. If voltage of internal resistance was high, Darshi, I don't understand what you mean. So 15 volt. Arshad, what are you saying? Okay, Darshi, I'll answer your question personally. I think that will be better, right? Y8, Swarali, we have to find the terminal voltage of battery, right? So this is the battery, right? 8 volt is the battery. This one is called supply in this question. I hope you understood that, right? So we have to find terminal voltage of the battery. Clear? So that's why 8 volt, because 8 volt is the EMF of that battery, right? Okay, fine. Arshad, check your calculations. I think you have put 1 here by mistake. It's not 1, it is 0.5. All right. Okay, so next time we will talk about why there is a resistor. You can also think about it. Okay, it's not a big deal, right? Yes, Avinash, you are right about that. It's costly if you do it this way, right? Okay, fine. See you tomorrow. Good luck for your physics exam. Okay, today was physics, was it? When is physics? Is it not tomorrow? Wednesday. All right. Fine. Then good luck for your maths exam also. No, Imani. Shortest answer, no. For more details, message me. Okay.